On test day, several questions will involve exponents. Though they may seem intimidating at first, all exponent questions can be answered correctly by using a few important rules and formulas. While you can use your calculator to find the exact value of exponential expressions, that can take a lot of time and often involves gigantic numbers. If you simplify the expressions first, you'll save time and confusion on test day. Exponents are expressions used as shorthand for multiplying the same number by itself a certain number of times. Instead of writing out 4 times 4 times 4 times 4 times 4, you can abbreviate this using exponent notation as 4 to the 5th power. When using this, the number you're multiplying by itself is known as the base. In this example, the base is 4. There are a number of rules for simplifying exponents. The first is, when you multiply one base to a certain exponent by the same base to a different exponent, you can simply keep the base the same and sum up the exponents. For example, 4 to the 3rd power times 4 to the 5th power can be simplified to 4 to the 8th power, because 3 plus 5 equals 8. So remember Rule 1. When multiplying the bases, add the exponents. The next rule deals with division. When dividing a base to a certain exponent by that same base to a different exponent, simply keep the base the same and take the difference of the two exponents. For example, 3 to the 6th power divided by 3 to the 4th power is simplified to 3 to the 2nd power, or 3 squared, because 6 minus 4 equals 2. That's Rule 2. When dividing the bases, subtract the exponents. The next rule involves a base to an exponent, then raised to another exponent. If you see this expression, you'll simplify by multiplying the exponents. For instance, quantity 2 to the 3rd power taken to the 4th power is simplified as 3 to the 12th power, because 3 times 4 is 12. And there we have Rule 3. When taking a power to another power, multiply the exponents. Did you notice that in the first two rules, you were multiplying or dividing a base by itself? Most of the simplification rules for exponents require that you're dealing with the same bases. In general, the first step with any exponent question is to get the same base. We'll look at this in more depth in a moment. For now, let's look at the only rule for simplifying exponents with different bases. When you're multiplying two different bases that are each taken to the same exponent, you can simplify the expression by writing the product of the two bases taken to that same exponent. Say you're multiplying 3 to the 4th power times 5 to the 4th power. You could simplify this by multiplying the bases, which gives you 15, and taking the product to the same power, 4. Be careful not to change the exponent if you're using this rule. Rule 4. When multiplying different bases to the same power, multiply the two bases together and take that result to that same power. You might see negative exponents on the test. It's important to remember that a negative exponent does not mean the number is negative. It simply means that you use the reciprocal of that exponent. A reciprocal of any number is 1 divided by that number. For example, 2 to the negative 3rd power is simply 1 over 2 to the 3rd. This gives us the final rule of exponents, Rule 5. Negative exponent, write it as 1 divided by that exponent. Let's try these rules out on a test question. What is the value of 2 to the 3rd power times 4 to the 3rd power divided by 4 to the 2nd power? The main rules for simplifying exponents need the bases to be the same. When you see a situation like this one on test day, try to express all the bases as the smallest base available. In this case, the smallest base is 2, so you need to rewrite the other exponents using a base of 2. This is easier than it sounds. You need to find a way to rewrite 4 using a base of 2. Is it possible to take 2 to some power so that it equals 4? Yes, you can write 4 as 2 squared. When you see this, rest assured, the test maker will give you numbers with an easy common base, like 2 and 4, or 3 and 9. Replace each 4 in the original expression with 2 squared. Now use all the wonderful exponent rules. Following the order of operations, take care of the parentheses first. Rule 3 tells you to multiply the exponents if taking a base to a power, then to another power. In the numerator, simplify 2 squared to the third by multiplying the exponents 2 and 3 to get 6. 2 squared to the third power becomes 2 to the sixth. Do the same thing in the denominator with 2 squared squared. Multiplying the exponents gives you 4, so 2 squared squared becomes 2 to the fourth. Phew, you're getting there. You still have a few rules to apply. Now that you have bases of 2, each with 1 exponent, use Rule 1 to simplify the numerator. When multiplying a base to 1 exponent times that same base to another exponent, you can add the exponents. 2 to the third power times 2 to the sixth power becomes 2 to the ninth power, as 6 plus 3 equals 9. Finally, you're left with a base to a power divided by that same base to a different power. Looks like it's time for Rule 2. Subtract the exponents to leave 2 to the fifth power, as 9 minus 4 is 2. Answer choice C is correct. To review, keeping track of these 5 rules will make exponent questions a lot easier. Rule 1. Multiplying the bases, add the exponents. Rule 2. Dividing the bases, subtract the exponents. Rule 3. Taking a power to another power, multiply the exponents. Rule 4. Multiplying different bases to the same power, multiply the 2 bases together and take that result to that same power. Finally, Rule 5. Negative exponent, write it as 1 divided by that exponent. Using these rules is essential. Remember, each step itself is easy, so it's not as hard as it might seem. Let's embed these rules into your brain by working through some guided practice.